Now, okay, so we are recording, and if I can get my notebook, please. There we go. So, study session, April 9th. We're going to come in here, add in some paper. Let me get all this. Zachary, would you please let Jesse know, because I can't reach him right now. Could you go out and tell him when he paints, I want yellow. I want the yellow that is in the laundry room.
That's not Alpha Pink, I got it.
It's not pink. I don't own pink, so I haven't gone to the store since all this coronavirus. It's got to go yellow. Make sure we have enough yellow paint. Okay, we now have paper in our notebook. And here we go. And WebEx is right there. And we're going to insert a screen. We'll just do one at a time, Saud, okay? So here we go. Oops, I did the wrong thing, I think. Did it go down to the bottom? It did. Hold on, I gotta undo that and redo that. Let's try that again. I thought I clicked up here, but evidently I didn't. There, now that'll be where the insert goes. Yes, honey?
Would you be okay with pink house pink?
That's exterior. That's exterior paint, and it will not. It has to be an interior paint.
Okay, because we have a whole of that left over there.
Yeah, if it's a latex paint, we can consider it. But if it's not, then we can't.
I don't know.
Ooh, I need the textbook. Where's that algebra book that I always use for my backdrop here?
Right here.
Thank you.
Yep, algebra.
Yep.
It's not algebra, but it's
There we
algebra.
go. Thank you. Alrighty, let me grab my stylus, and we are getting ready. Okay, so here we go. So let me get and I want to make sure we're actually recording. We are. Okay, so here we go. Let's get the notebook opened. All right, here we go. So here's the logic of what we're doing. Let's go back to basics here. I'm just going to show you a different picture to begin with. So when we start off, we have our normal distribution, the bell-shaped curve. What we know is that the area under the curve, under this whole thing, this whole area, and I'm talking, like the area that, like if you had a room and you were putting carpet in the room, you would have to measure the square footage on the floor, and you would have to order that much carpet, okay, that many square feet to cover the area. So we're talking a physical area. And what we have right here is the physical area under this curve right here. Underneath all of this is 1.0. The whole area, the sum, the total area. This is total area. So this is total area. Okay? And what we do is we say that we're going to let the area under the curve represent the probability of an event. So in essence, what we're saying is the total area equals the probability equals probability. I'm just going to say probability, okay? So in this case, if I say my area under the curve is 1.0, then that means if I were to look at the probability of an event happening, and the probability was this whole great green shaded area, then the probability of the event happening is 100%, okay? Because we would take whatever the area is in order to get, to put it in a percent. Thank you. Put it within my reach. Thank you. That's good. Thank you. in order to get percent, we're going to take the area and multiply it by 100. Okay, so it's going to be area times 100. That's going to give us the percentage. Okay, to put it in a percentage. The area, though, is the probability, okay, of the event happening. So let's say that we have this. And we're going to talk about one particular curve in particular. It's called the standard normal curve. And the standard normal curve, what we know about that, well, let's go back up to this one real quick. Let me just go ahead and draw another one like this. So if we have the exact same curve, and we're talking about just an event happening, we can say that we can have half of the area here, half of the area here, because it is symmetrical. And we know the whole area underneath must equal 1.0. So since the whole area equals 1.0, and we know that it is symmetrical about the mean mu, where we have 50% on the left side of mu, 50% on the right side of mu. And that is because we are dealing with a normal distribution. So this is a normal distribution. Salud, so far so good. Let me come back. I'm asking you a question. If you could respond. Are you doing... let me minimize that. Thank you. Okay, so now we have a special distribution called the standard normal distribution. And the standard normal distribution is a normal distribution, except for we standardized it. We put it on a standardized scale. And what we said is mu is always going to be in the center, and we're going to represent mu by the number 0. Okay, so we have a standard normal distribution. This is our standard normal distribution. Okay, and we put the mean in the center, and it's 0. And what we know about the standard the standard normal is the number 1 is, if it's a positive 1, this is 1 standard deviation above the mean. This number right here is 1 standard deviation below the mean, okay? And when I'm looking at this, each data set has a different mu. The standard normal, it's always 0 for the mean. 1 represents 1 standard deviation above the mean. -1 always represents 1 standard deviation below the mean. The number 2 always represents 2 standard deviations above the mean. -2 always represents 2 standard deviations below the mean. The number 3 right here always represents 3 standard deviations above the mean. The number -3 right here always represents 3 standard deviations below the mean. And the area under the curve in relationship to these numbers is consistent, okay? Because it's a standard, okay, so it's consistent, normal distribution. These numbers right here, all of these numbers, this number right here, this number right here, this number right over there, that one right there, that one right there, that one right there, that right there, in any other number along this bottom axis. It has to be along the bottom axis here. Any number that's on that axis is a z score or z value. Those are your z scores, z values. Where in here, this is the area again. okay? Or probability. Okay? Oh, my computer is having some issues. Hold on. There we go. So probability. There you go. Dropped my eyes. Okay. So, and did it drop my Z? No, it didn't. Okay. So, Saud, how are you so far on this concept? Are you understanding my graph and where the numbers are and what they represent? Okay, great. Now, your question here said, it says find the normal for a normal distribution. Okay, find the z-score that cuts off the bottom 79.57% of all z-scores. Round to 2 decimal places after the decimal point. Okay, now remember that this in here is area. And according to your actual problem here, it says the area is 79.57%. But I'm going to rewrite the area as 0.7957, because that's what we have to do when we have a percent. When we have the percent sign, before we can do math, we have to move that decimal place, move decimal 2 places to the left. So that's what I did. I took this decimal place and I moved it 2 to the left, so it became 0.7957. So far, so good. Great. Great. Okay. Now, the question is, find the z-score. Remember, where is the z-score located on this graph? I want an answer would like you to type in your answer. Where is the z-score found? On the axis. That's correct. Saud, do you agree? Do you understand that it's on the axis? Great. Very good. Thank you for the feedback, guys. So now we're going to open up. Let's go back. So what we're going to do is we have to find the z-score that goes on the axis down here that corresponds to 7.7957 area under the curve to the left. That's in the gray area. Okay? So now we bring up our tables, 79.57. So we're going to bring up our tables. Notice that your tables are set up where they give the area to the left. But when we go back and we look at this, do you see that this number right here is greater than 0.57? So, oops, I'm throwing my computer. Hold on. Let me grab my computer again. So, 0.7957 is greater than 0.5. Because this number here is greater than 0.5, I know my z is on the right. Because remember, we looked at this picture and we said that we have 0.5 over here and 0.5 over here. Well, if the total area to the left of the z value has to be 0.79, if the total area is going to be to the left, the only way I could do that is to draw the line over here to the right, because I have to be able to take 0.5 from the left and some of this area in here to ensure that to the left I have 0.7957. Are you good with that? That can be a difficult concept. Are you all good with that? Thank you. Thank you. Okay. So that's how we knew that the total area up here had to be shaded and the z is to the right. Well, the z is to the right. When we look at this, let's look at this one here. Remember that on this picture right here, we have, oops, 0.5 on this side, and we have 0.5 on this side. If I have to have 0.79, are my z values, the numbers along the axis, is it going to be a positive number or a negative number in order to put 0.7957 to the left of my z value? What type of numbers do I have over here? Positive or negative numbers? Exactly. So that tells me that I'm going to look at my z table, and I'm not going to look at the negative, because right here, oh, I can't write on this part of the screen. Right here are my z values. These are my z values. And this in here is the area. So this is area. Here, let me go ahead and insert a z table into the notebook here. Let me go ahead and grab it, and I may have to close it to insert it. I don't know if I can insert it while it's opened. It will let me know though. Okay, so here we go. Here are my tables inserted for us to use. Now I can write on them, and I think that'll help. Okay, so right in here, my z values, I think we did blue for z values. So right through here are my z values. Here's my z values all through here. Okay, these are my negative z values. Those are to the first decimal place, and then this is to the second decimal place. Those are my z's. The area under the curve are these numbers in here. This is area right here. This is the area under the curve. So when I go and look at the other set of tables, these are my z values, but these are the positive z values. Again, here's my positive z's to the first decimal place. First decimal place all the way through here. And then here's the rest of my z. And this is what we're being asked to solve. We're asked to solve the z. But with the area, which is in here, this is our area in here. This is our area, equal to 0.7957 if I'm correct. Let me double check that. I'm pretty sure I have that correct, but let me just go back up and double check. So I do not want to do that wrong. 0.7957. So coming in here, so 0.7957 is what we have to find. So we're going to look in the area for 0.7957. 7957. Is that it right there? That might be it right there. That's 67. I don't see 57. Can somebody tell me whether or not, just type on there, do I have an exact answer? I would have expected them to have given us an exact answer, but it doesn't look like that. It looks like this is going to be the closest one, 7957. Let me come back in here and, oops, cancel. They don't give an exact one. Thank you. So let's see what we have. Whoops, I went the wrong way. So the closest one to me that I see is 0.83. Positive 0.83. And is that what you sent me in the text that you put in as the answer? Let me look. No, you put in 0.79 is what you put in. So Saud, on mine, I guess this is my answer, not yours. So it should be 0.83 and submit answers. Let's see if that comes up correct. It does. Okay. So Saud, are you good on that? Are you understanding so far? Are you there? Okay, so let's look at the second one here of my work, okay? So I'm going to insert this one right here. But what you said, it's not 0.79. Correct, it's 0.83. Because it asked for the Z. The question is, what is the Z? And the area is 0.7957, but it asked for the Z. The Z is what's highlighted in blue, so I have to come back over here. I have to come to the left and go up above to find the Z. I put this and this together to make the number 0.83. The 0.7957 is the area. It asked for the Z. Are you understanding? That's right. You have a different number. You have to solve your own problem. I'm teaching the concept using my numbers, and then you have to take the concept and apply it to your numbers to get the right answer. So let's do the last one here of mine, and I've got a hypothesis test from another student. So let's go ahead and insert the next one here. Yes, okay, and then we'll go to the next problem. So, excuse me. So coming back up here, again, you're going to look in here in the area because you have to pull up your Z tables and you have to look in here under area. And we were told to find the Z value that corresponded to the area under the curve equal to 0.7957. We don't have that exact number, but we have, this is the closest number right here to that. Is 0.7967. It's not 57, but it's the closest number that I have. So now this is the area under the curve. So in order to find the Z value that is associated with this area, you come over here to the left and you see 0.8, and then you go up here, 3. So that's how we get it, 0.83. Okay. So let me see here. I had another student text me, and it said, can we do problem 11 on WebEx this morning? Problem 11, let's see here, who am I speaking with? I don't have a name on this. It just says problem 11. It's a 727 area code, no name, but it doesn't say, oh, it's Peyton. Peyton, are you here? You don't, mod 8, thank you. Okay, got it. So we're going to pull up mod 8, number 11. And let's come up here and we'll come up to homework sets. Number 11 on hypothesis testing. Here we go. And Peyton, if you have a question as we're going through, feel free to unmute your mic to interact and ask your question with me. If you have a mic, you may not have one. Okay, so it says your statistics instructor claims that 55% of the students who take an elementary statistics class have an appreciation for the subject. We all know that that's a low estimate. All of you guys love the subject, so it would be much higher, but you know, okay, yes, I'm laughing. Okay, for some reason, she can't quite figure out, most people don't believe her. Yeah, there we go. You decide to check this out on your own. You randomly survey 55 people of her past elementary statistics students and find that 34 34 claim to have to appreciate the subject as a result of her class. Do we detect that the actual percentage of students appreciating statistics is different from 0.55? Use alpha is equal to 0.01. Let's write down what we know from this. I want to make sure that I'm recording it. Sometimes I pause when I'm opening up different things. Nope, we're recording, so that's good. I just wanted to make sure. If I can bring that back up, I can't, so I'm just going to go like that. There we go. Alrighty. So it says, what is the null hypothesis? So the null hypothesis is going to be, let's see here, we're doing percentage. So because it's percentage, it's not a mu, it's going to be P. So it's going to be that P equals 55. So it's 0.55. And then it says the alternative is that P, because it says different, means not equal to 0.55. So far, so good, Peyton. Okay. So we'll just go ahead and throw this in real quick. So this is going to be P. It's going to be equals. I don't like web work on this part here because we should be able to make the null opposite. Well, in this case, it would be equal to, would be opposite. But I think it should allow it to be greater than or equal to or less than or equal to as long as it's opposite. But it doesn't. You have to put in equal always. So I guess that's their not equal sign. 0.55. Submit answers. So far, so good. Here we go. Now it says, is this a T or a Z? Peyton, what's the answer? Why? And yes, you're correct, but why? Are you typing an answer, or is it just a long answer, or you don't know the answer? No. The reason why is because it has to do with proportion. Every single time you deal with proportion, whether it's confidence intervals or hypothesis testing, you're always on a Z. Okay? So it's because you're always on a Z. Let me, since we're recording, I want to make sure I try to see who else here. Thank you. Okay, so it is a Z. We'll put that up here. It is a Z. And so how do we know it's proportion? Okay. Because it says in the problem right here, it says your statistic instructor claims that 55%. When you see the percent, I'm not going to say always because there's like one homework problem, I think, in web work where they have the average and they have a percent or something and it's actually a mu. But on my exams, I can't say about the final. I am not making the comprehensive final exam. Let me just kind of let you guys know that. I'm influencing the final exam. I am not making the final exam. I am making your next exam. The final exam is being made up by the professor that heads up the Elements of Statistics course at UWF. And so, like I said, I have influence on it, but it's kind of like if you all took me for college algebra, you know I never made any of those exams because the head of the college algebra makes up all the exams. We're going to be back in the same scenario. Normally I would make my own final, but because things are being done differently this semester, the Elements of Statistics head is making up that exam. So just to kind of give you a heads up on that. So, but when I make your exam, if you see the percent there, you're going to know it's proportion. Okay, but let's look in the wording here. It says, for some reason she can't quite figure out. She decided to check this out on her own. Blah, 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 blah. Do we detect that the actual percentage, okay? So when you see percentage or proportion of students appreciating statistics is different from 55%. So the percent sign here and then the word percentage or proportion are the two words you're going to be keying in on in the written word, okay? Does that help? You're welcome. Okay. So it says find the test statistics. So here we go. Let's grab our formula sheet because we have to have our formula sheet because that's where we're going to be getting our stuff from. And we're hypothesis testing, so it's on page 4. And we're doing one sample hypothesis test for proportion. Here is our test statistic right there. And you're going to see that for proportion, the only thing we have is a z. So a t isn't even an option for that. So let's come in here and we're going to put right here if I can. I don't know that it'll let me insert right there or not on top of another picture. We're going to try. Nothing ventured, nothing gained. Ah, it did. So we'll just move it over here to where it will work well for us. Well, okay, maybe I need to put it down there. There we go. Okay, so there's our formula for our test statistic. And so we have z is going to be equal to p hat. Well, p hat is, let's see here, so n is 55. That came from right here. X is the number of students that claim to have been enriched or appreciated statistics. So X is equal to 34. So P hat is equal to the ratio of X divided by N. So P hat is equal to 34 divided by 55. So we grab our calculator and we go 34 divided by 55 is equal to. Proportions are highly sensitive. When you do your calculations, always go out to at least 6. On the proportion problems for web work, whoa, I have no idea what happened. It just kind of happened. There we go. For web work, we end up, you just need to put this number or this ratio in your calculator and let it run, because otherwise it's not going to give you the correct answer for web work. Okay, so round it to 4 decimal places. Our test statistic, oh, we haven't finished that yet. So that's p hat. P is what's in your hypothesis. Okay, that's what we have historically known to be our proportion. So P is equal to 0.55. Q is equal to 0.45 because that's 1 minus P, okay? And here's your formula, by the way, for P hat. Now we're going to use all this information to calculate our test statistic. So it's going to be Z is going to be equal to P hat. P hat is right here. And I'm in your calculator, I'll show you, I'll bring up the calculator and show you. Let it run 34 over 55, because otherwise it's not going to possibly give you the correct answer. So it's going to be P hat minus P, 0.55. My computer is 4 years old, guys, and I'm sorry. Sometimes it has a hard day, and today it's having a hard day. I wish I could afford to order a new one and get it in time to do benefit for you guys, so I didn't have those issues. Okay, divide it by the square root of, this is P, not P hat, so it's 0.55 times 0.45 divided by N. N is 55. All of that is underneath the radical. So we're going to put this in the calculator like so. We're going to make sure that we use double parentheses right here because I need to lock in my numerator and I need to lock in this division. So I'm actually going to use a second set of parentheses like that when I put it in my calculator. So let me open up the calculator here. And so I'm going to open up 2 sets of parentheses, 1, 2, and then it's going to be 34 divided by 55, close parentheses, minus 0.55, close parentheses, divided by the square root of 0.55 times 0.45 divided by 55. And then you hit enter. So just make sure you realize that this is 0.55. There's a decimal right there. This is your sample size. This is your proportion. And hit enter. And so our test statistic is 1.016394535. And it says round to 4 decimal places, so it's going to be 1.0164. So it's going to be 164. It's going to be, so that's going to be 1.0164. And that is it to 4 decimal places. So we come in here and it's 1.0164. Submit answers. And there you go. We have that correct. Now it wants the p-value. Well, we're testing at alpha is equal to 0.01. So let's get our picture drawn that shows what's going on for this particular problem. For this particular problem, we have a two-tailed test, if I recall correctly. Is that right? Yeah, we have a two-tailed test, and it's going to look like this. We're going to have a picture. Looks like this. We're putting mean in the center, and we have alpha is equal to 0.01. So alpha is equal to 0.01. Therefore, half of alpha is going to be 0.01 divided by 2, which is equal to 0.005. We're going to put our critical values in here, and because it's a two-tailed test, we're going to have a right and a left z-star. We have a negative z-star, and we're going to have a positive z-star. And our z-star is going to be equal to the z-value to the area under the curve is going to be 0.05 or 0.005. Whoops. Put one too many there. And then in here, because we're doing a 99% confidence is what we're doing, in here we're going to have 99. Okay? This is our fail to reject. This is our reject. And here and here. Okay? And if we want to highlight, we can highlight and we can say this is the rejection zone. We have a rejection zone on the left as well as one on the right because it's a two-tailed test. And then we have our fail to reject area right in here. Okay, so there's our fail to reject area. Excuse me. So now we need to find our z-star. So I'm only going to look up one because they're symmetrical, and whatever my negative value is, the z positive is going to be the exact same number, just a positive version of it. So I'm going to look for 0.005, and I'm going to bring up our z-tables. And I'm going to look for the area under the curve, which is in here at 0.005. And so I have 0.003, 0.004, 0.005 is going to be right in between these two values. And so I'm going to look for negative 2.58 is what I'm going to use as opposed to 5.7. I would love to use 5.75, but we'll use 5.8 instead. So this is going to be red. Okay, so this is going to be equal to negative 2.58, and this is equal to positive 2.58. Okay, so those are our critical values. And if I my test statistic falls to the negative of negative 2.58 or to the positive of 2.58, then I'm going to reject my null hypothesis and conclude that the alternative is correct. So we come in here and we plot our test statistic, which was 1.1064. We're just going to put 1.02 because that's to two significant places, just like our z-score. And you're going to see that we plot our z in here, our test statistic. So this is our test statistic. And this here is our critical value. Okay, so do we reject or do we fail to reject, everybody? Very good. Andrew, I just saw your question. I'm sorry that I didn't answer it earlier. We know it is a two-tailed test because of this one factor right here, because it says not equal to. Okay? It says we're looking for, is it different? So let me ask you a question. If I say, your bank account balance is approximately, okay, approximately $50. And in reality, you have $1,000 in there. Would you say, let me rephrase that. Let's do this one. Yeah, okay, let's do that. So yeah, let's say I say you have, I think your bank account balance is $50, but in reality you have $1,000. Would you say that that is different, Andrew? Whoops. Okay. What if I said that that your bank account balance, I think, is approximately $50, but the reality is you have a negative $1,000 in your bank account. Would you say that that is different from $50 bank account? Okay, so that's how I know it's a two-tailed. When I'm saying it's different, it doesn't matter whether it's different in the positive direction or different in the negative direction. It's different, okay? So a two-tailed test says, I'm not worried about direction. If it's either way too big or way too small, it's different. Or another key word that you want to look for a two-tailed test is change. So if it has changed, if something's changed, if it grew huge or shrunk very small, it changed. I'm not saying I think it grew big or it grew small. I'm just saying I'm looking for a change. So when you're looking for a difference or that something has changed, you don't care whether it grew or shrunk. It's the fact that there has been a change, and so therefore that is different. That makes it a two-tailed test. You're going to look at both directions to see if there's a shift. If it is a one-tailed test, it's going to say, I think that your bank account balance is greater than $50. Okay? So the only time I would be wrong is if you actually had a negative $1,000 balance. Does that make sense? Good, thank you. So one-tailed tests are directional, where a two-tailed test is either direction. And in addition to bank account balances, one of the other things that you can think about is nuts and bolts. If you're manufacturing a nut or a bolt, and it has to meet certain specifications to work properly, okay? If you're ordering a bolt and it's too large, it's not going to fit in the hole. And if it's too small, it's going to jiggle and possibly shear off. So that's another indication of difference. So just to kind of share that with you. Okay, back to the problem here. So it's asking for p-value. So here we have our picture of what's going on. We know we're going to fail to reject. Now what we're going to look for is our p-value. And because it's a two-tailed test, our p-value is a little differently. So our p-value is calculated like this. Because it's a two-tailed test, we have to look at two areas. We divided alpha in half. We had to share our alpha between two tails because it's a two-tailed test. Because of that, we have to do the same with our p-value. We only have one area, and this is the test statistic, but we have to double it. So our p-value, I always like to do p-value in purple because p and p, okay? So anyway, so here's our p-value area in purple, and we have to double it because it's a two-tailed test. So our p-value for this particular test is going to be huge. And our number, we're going to look up 1.02 in our tables here. 1.02, it's a positive value, so we're, well, because I understand symmetry, we're going to look up the negative, because I can look up negative 1.02, this number right in here, and know that that area under the curve over here is going to be the exact same. And the way your z-tables work, it's easier if I look up negative 1.02. Negative 1.0, so 1.0000102. So it's 1539. So in here, it's 0.1539, and in here, it's 0.1539. On this part here, is everybody with me? Did I lose anybody? Just tell me that if you have a question, let me know. If you're good, just say got it, or yeah, yes, whatever. But if you don't understand what I'm doing on the p-value, please stop me now so I can help out. Okay. Thank you. You're lost. Okay. So I'll repeat it one more time. So your p-value is based off of your test statistic. So you have to look up your test statistic right here. Find the area under the curve. Because it's a two-tailed test, we have to do a right and a left area. So to calculate our p-value in that case is it's going to be equal to your p-value, because it's a two-tailed test, is going to be, it's really equal to the probability that z is less than negative 1.02 plus the probability that z is greater than positive 1.02. Or I can say that it is what's the number? 1539. 0.1539. That's that area right there. Plus 0.1539. Or I can just say it's 2 times 0.1539. Okay? All of those say the exact same thing. I'm putting it in. 0.1539 times 2 is 30.78. That's huge. Okay? That's very huge. There's not even a remote possibility that that's a difference. Okay? So 30.78. 0.3078. Submit answers. And there we go. And then, so my conclusion is it says the first thing you have to decide is, are you rejecting or are you failing to reject H naught? Well, we're going to fail to reject H naught because we were in the green fail to reject area. And that means there is not sufficient evidence to conclude that we are different from 55% for her students' appreciation of statistics. And I'm trying to remember who asked that question to begin with. Peyton, was it? Yeah, Peyton. Are you good? Okay. Where were you going wrong, Peyton? Okay. All right. Do you understand why I use the formula that I use now? Okay, good. All right. I had another text come in. Let's see here. I have, let me see here. Who is this? Christian, are you on here right now? I just saw that I had a text from you saying that you can't find the link. Did everybody here use the link in Canvas to get there so I can reply to Christian that he just needs to go to Canvas? Okay, thank you. So go to Canvas. It's posted there and working. Okay, so hopefully Christian can join us now. Okay, so number 14. On 14, let me flip on over to 14. So that's problem 11, 12, 13, and 14. Mean entry-level salaries for college graduates with mechanical engineering degrees and electrical engineering degrees are believed to be approximately the same. The recruiting office thinks that the mean mechanical engineering salary is actually lower than the mean electrical engineering salary. The recruiting office randomly surveys 50 entry-level mechanical engineers, sample 1, population 1, and 60 entry-level electrical engineers, population 2. Their mean salaries were $48,000 and $49,000 respectively. Their standard deviations were $3,450 and $4,210 respectively. Conduct a hypothesis test to determine if their mean entry-level mechanical engineering salary is lower than the mean entry-level electrical engineering salary using alpha equal 0.05. I'm more than willing to work this all the way through. Is that what you need, or do you just need me to confirm whether it's a t-test, Jessica? No, just the T. Okay, well, let me look at it a little bit closer, and I will double check for you. I'm going to read it with that in mind. So, yes, it is a t-test because the standard deviations came from their from the samples. So it is a t-test. So are you good? Because it's a sample standard deviation. Exactly. That is exactly right. Okay. So what I'm going to do, hey, sweetie, is I'm going to look up a couple of problems that I want to go over because we're running a little bit out of time. And this will be our last time getting together for a little bit before the exam. I think I'm going to, I can't commit because I have doctor's appointments scheduled for Monday morning. But I don't think the doctors are keeping their well visits. I think they're canceling them, but they haven't called me to cancel yet. But on Monday, I should be good for an afternoon study session. So I will announce that probably Sunday if I'm able to do that. I'm hoping to be able to do an afternoon, like maybe a 2-hour or 3-hour, where you can just bebop in, bebop back out, but you know that I'm going to be on WebEx if you have questions and want to talk about things. So I'm looking at an older textbook here for a particular type of problem, but I'm not seeing, it's not jumping out at me, so I think I'm just going to make one up because I want you guys to realize that you have the means You know, if it's one in a textbook, you know it's going to be it's going to work out nicely. Okay, so here's one. Let me see here. Let me look. A company claims that. Okay, so yeah, here's the first one, and then I'm going to do a second one. Okay, so this will be the first one. So I'm going to type this up real quick. Let me get in here, and let me just come right there. And it says, a company claims that its 8-ounce low fat yogurt cups contain on average at most 150 calories per cup. A consumer, those consumer agencies get us every time. A consumer agency wanted to check whether or not this claim is true. Thank you, Zachary. Oh, that's a claim, not a claim. Let's see here. Claim is true. A random sample of 10 such cups produced the following data on calories. Okay, here we go. So we have 147, 159, 153, 146, 144, 161, 163, 153, 163, 153, 143, and 158. Okay, and then it says test at the 2.5%. Where's a significance level if the company's claim is true. Assume that the number of calories for such cups of yogurt produced by this company has an approximate normal distribution. Okay, let me correct my one spelling error there, and that's the problem. I'm going to give you guys like, I don't know, 2 to 3 minutes to work this problem on your own. Let me make it big enough where everybody can see it. I think this will do it if I can. There you go. And I'll bold it, and then that should make it stand out a little bit better for everybody. There you go. So there's the problem. I'm going to give you guys 3 minutes to work on this problem. I'm going to set my timer, and then I'm going to slowly come in and start working on it. Okay, guys, how did you do? Did you get started on it? Anybody still there? Anybody hear me? Still working on it. That's good. Got started. Very good. Kaylin, Jason, Emily. Okay, so here we go. A company claims that its 8-ounce low-fat yogurt cups contain, on average, at most 150 calories per cup. That's average. A consumer agency wanted to check whether or not this claim is true. A random sample of 10 such cups produced the following data. Here's our raw data. Test at 2.5% significant level if the company's claim is true. Assume that the number of calories for such cups of yogurt produced by this company has an approximate normal distribution. So it says that it is at most 150. Hold on a second, guys. I need to talk to my family for just a second. Hold on. Sorry. Keep working on the problem. Mike. There we go. Can you all hear me now? Sorry about that. My husband's running to the store for me, so I had to make sure he had the shopping list. I apologize, but that's the way it is. Okay, so here we go. Alrighty, so it says company's claims that its 8-ounce low-fat yogurt cups contain, on average, at most 150 calories per cup. The consumer agency wanted to check whether or not this claim is true. A random sample of 10 such cups produced the following data. Test at a 2% alpha level, 2.5% significant level. If the company's claim is true, assume that the number of calories for such cup of yogurts produced by this company has, on average, is normally distributed. So here we go. So if we're going to test that it's true, what we're saying is we're going to assume it's true unless I can prove beyond a shadow of a doubt that what they're saying is wrong, okay? So that means that my alternative hypothesis is going to be that mu is greater than 150, okay? They're saying it's less than 150. So if, as a consumer agency, if I'm checking, I want to be able to go to them and say, I've proven statistically that you are wrong, that your average is higher than 150. So that's what we're testing, is that mu is higher than 150. Are you looking for the keys to the truck? Ask Jesse or look in my nightstand, honey. They were on the table. I don't know. I'm sorry. Check my pockets of my jeans that are in the bedroom maybe. But I haven't driven the truck lately, so I don't think I had them last. Okay, so there is the hypothesis. Is everybody good on the hypothesis? Before I go any further, let's make sure everybody's good on the hypothesis. Any questions on why we have the hypothesis the way we're doing it? Okay, Jessica, thank you. Okay, good. Now, the next thing is we want to write down our information, is that n is equal to 10. And I have to be honest, I was helping my husband, so I wasn't calculating. So let me get all this information. Actually, you know what? Since you guys are here, anybody who wants to watch this, I post it, they can watch it. The reason I'm doing this is because you're likely going to see this exact same type of concept and this type of test on your next exam, okay? And you definitely will see it also on the final exam. So where I give raw data. The reality is I don't have to give you sigma. You all know how to calculate sigma at this point. I don't have to give you X bar. You know how to calculate X bar. It's locked in the glove box. You're going to have to take the keys out with you. I'm sorry, honey. So we're going to calculate X bar, and we're going to also calculate S. And in order to do that, I'm going to show you some shortcuts here, guys, that normally I don't teach, but I normally teach this. Okay, so what I normally do is I teach this concept between exam 3 and the final exam, okay? But I recognize that since not everybody's going to take the final exam, I'm going to go ahead and show you some things now because I really want you to understand the concept, not the calculator. But I'm going to go ahead and show you this, and I'll probably go ahead and upload some different videos. If I upload videos and I post, my recommendation is this for you to kind of check them out a little bit, okay? Because in my other videos that I haven't posted yet, but that I'll upload, I show different type of shortcuts. So this is beneficial if you have the TI-84. If you don't, it's okay too, because you know how to do it and you know how to get some of the shortcuts in your TI-30. So you're going to turn on your calculator. I'll just do it in here. And we're going to go to the stats function and we're going to hit enter. And that brings up your list. If your list is not cleared, go up so that the L1 is highlighted and then hit clear and then hit enter, and that will clear the whole list. I know so many students that clear one item at a time, and that's absolutely not necessary. So now we're going to enter in our data. So it's 147. So I'm going to do 147, enter. Then I'm going to do 159, 159, enter. I'm going to do 153, 153, enter. I'm putting all this data into my calculator. 146, 146, enter. 144, enter. 161, enter. 163, enter. 153, enter. The nice thing about the TI-84 also is that you can see if you make a mistake and correct it. That is an advantage that you have with the TI-84 over the TI-30. Okay, now I have everything entered in, and I know that I have everything entered in because it says I'm looking for the 11th entry, and I have my 10 entries. Now to get my X bar, I come over here and I hit stat, and then I go over one time and to where it says calculate, and I'm doing one variable. Okay, I only have one set of data. I don't have two. For mod 9, we're going to have two sets of data, or if we were doing the hypothesis test or confidence intervals with two populations, we could have two variables, okay? But right now I only have one, so I'm going to put one, I'm going to hit enter. The next thing you want to do is you want to make sure that you have L1 selected, because there's so many different lists, and I use my different list, so I have to make sure it says L1 because I wanted to do the calculations on list 1. And then just hit enter until you get down here. And now it's giving me my X bar. It's giving me my summation of X, my summation of X squared. And then it's giving me my standard deviation. You'll notice that you have S and then you have sigma. For this course, you will never use the sigma that's provided in the TI 84. You just don't use it. You're only going to use the S sub x. That's the sample standard deviation. That's the one that uses the same calculations that I teach. The other one is for population, and we don't ever have a need for that in this course. So now we're going to write down our summary statistics. It says that my X bar is 152.7. And so let me come over here. And it says X bar is 152.7. So I'm going to put an equal sign right here. 152.7, I think is what it was. Let me bring it back up. Yes, and then my standard deviation is the 7.3794. So 7.3794. Oh, shoot my memory. Sorry, guys. Hold on. 3794. 3794. Okay. So now let's look at our alpha. Our alpha is going to be equal to 0.025. And let's get our picture drawn for our situation. We're going to have this right here. In the center is our mean. Our critical value is going to be right here, Z star. It's going to be on the right-hand side because I have a right tail test. Remember, in the alternative hypothesis, it points and tells you which end we're looking at. And so it's 0.025. And so this is going to be our reject area. Reject. And this right here is my fail to reject. It's a T, okay? So we need our degrees of freedom. So we're going to look at 0.025, comma, 9 degrees of freedom. And we're going to come in here and grab our T. So that is right here. So it is a one-tail test at 0.025, which is right here, 9 degrees of freedom. And so our critical value is right there. Does everybody agree? So it's 2.262. 2.262. 2.262. So right here is going to be a positive 2.262. Okay, anybody who's listening, just say I agree or I don't. I'm going to mute for just a second because my husband has a quick question. Okay, so let me see what everybody said. Everybody's good. Okay, how many of you caught the fact that I goofed on the Z and T? Why didn't? How many people felt like screaming but just didn't scream at me? Nobody? Okay, that's okay. It's a sample standard deviation. I did not scream haha, but did you catch it? But did you catch it? Very good, Ashley. I'm glad to see that. I got that it was T, but I didn't realize that you were doing Z. Okay, that's fair. That's fair. So thank you, guys. Here we go. Moving right along. Into here. So now we have our picture set up properly, and now we need to do our test statistic. So our test statistic is going to be T, and that's going to be equal to, it should be X bar minus, oops, that should be a minus mu divided by S divided by the square root of N. But I'm going to go double check it because my memory isn't always accurate. So we're going to come in here. We're doing a one sample test where sigma is not known. There it is, right there. There's our formula, which is what I just wrote down. And so we're going to plug in our numbers. And we ended up with 152.7 for our mean. 152.7 for our mean minus mu, which is 150. 150 divided by our standard deviation. Our standard deviation is 7.3794. 7.3794. 0.3794 divided by the square root of n, which is 10. And we're going to put this in our calculator. Turn that on, hit clear, and we're going to go parentheses 152.7 minus, there we go, 150, close parentheses, divided by, open parentheses right here, 7.3794, divided by the square root of 10. Come out from underneath the radical, close, hit enter. And there's our test statistic. That's 1.157. So 157. So 1.157. So we're going to come back up here to our picture, and we're going to put 1.157 right there, and we are on the fail to reject. So we fail to reject. Okay? Is everybody, let me look at the time, guys. I've got 10 minutes left before my algebra class. Is everybody good so far? Thank you, Jason. Okay, now I'm going to show you a shortcut. Now, does anybody here have the TI-84? If not, then I don't need to show you this. Okay, good. So if you don't have a TI-84, but you decide that you would want one, I would encourage you to look at eBay. But I don't know that you could get it in time for you to get familiar with it, but maybe a friend or somebody has one that you could borrow, okay? But eBay is always a good place to shop cheap TI-84s. That's where I get mine at. Okay, so here we go. So here's our information. I'm going to clear this out. We have in here our list. Here's our raw data. I'm going to come over here to stat, and I'm going to come over here and I'm going to hit test. And I'm going to be doing a t-test, okay? I'm doing a hypothesis. You can kind of scroll through here and see we have hypothesis testing, we have proportions, we have lots of different things through here. And it's been a while since I have been in here, so it may take me 2 attempts to get through this. I don't think it's I think it's this one here that I need, I think. We're about to find out. And so I have data. If I provided for you X bar and S, the summary statistics, then you would have statistics. That would be summary statistics. But right now we have the raw data in our list. Okay, so we have data and that's highlighted. And we're going to come down here and it says, what is mu? Well, mu was 150. So right here we're going to put 150. Okay. And then it says, what list do you want me to use? I have list 1 because that's where my data is. And then right here, frequency, I have no clue what that means, so I just skip over it. And then you come in and you click on your hypothesis, your alternative hypothesis. And this is what our alternative hypothesis is. So I have that highlighted. I'm going to hit enter, and then I'm going to come down. I don't want it to draw it for me. I want it to calculate it. So then I'm going to hit enter. And now it comes in with my test statistic at 1.157. You can see it's the exact same number, okay? This gives you the p-value right here. Now, when I ask for the p-value on the test, I'm going to be doing the interpolation. I might take this value. I don't know. I haven't quite decided. I really want to have everybody test it the same, so you're probably going to have to interpolate it. And then we have our X bar, we have our S, we have our N, and so it tells you right here. It doesn't tell you whether you fail or you don't fail to reject, but it gives you your test statistics so you can plot it on here, and it does give you your p-value. So you could take your p-value and compare it then to your alpha, and you can see that this is greater than your alpha, therefore you would fail the test, okay? If, since I have everybody here real quick, if I was asking you to do a confidence interval on this same data set, it would look like this. It would be under test, and I would come down to T confidence interval because this would be on a T test, and I would hit enter, and it would say again data, list 1, skip the frequency because I have no idea what that means, and let's say I wanted this to be at 0.975, so I put 975, so I'm at that same confidence level there. So you can change that number there, and then you hit calculate. It takes it a moment of thinking, and it comes up with your confidence interval. It gives you your X bar, your sample standard deviation, and then your sample size. So this is recorded, so you can back this up and watch it again. I think, oh yeah, I have algebra in like 5 minutes. I don't know if that was beneficial to Rowan and Jessica or not, but normally I don't show those shortcuts until after the third test because I really want you to understand the concept, how to calculate everything by scratch. But anyway, was that helpful to anybody? So you're welcome, and keep an eye out. I will be posting videos that have shortcuts just like that for the TI-84 and other things. You will have raw data on your upcoming exam, and we can do the exact same thing with proportions. Let me just say, if I give you a hypothesis test for proportion, I can say, you know, maybe the answers were yes, no. So if I say here's the results, yes, 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 no, no, yes, no, yes, no, 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 yes, no, no. So let's say this is my sample data right here for proportion, a hypothesis test, and I would say that X is my yeses, then my N is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So N is equal to 16. My X is equal to 1, 2, 3, 4, 5, 6 is equal to 6. Therefore, P hat is equal to 6 divided by 16. And so for a hypothesis test, even though it's small data, it's still on a Z, but I give you the raw data and I tell you that you can go ahead and do the test, and this is how you would calculate P hat. And then in the problem, I would say maybe I think that the proportion is really 0.35. Is this any different? Because this ends up calculating out at 0.375. So maybe in the hypothesis wording, I say I think it's 30% or 35%. We did a survey, and here's the results. Well, from here you can calculate everything you need because all you needed was an X and an N when you come in and you look at this formula right here. Okay, all you needed was X and N, and then the P. And if I said, you know, is it different than 35%? You've got everything you need to do that calculation. Does everybody understand that? Is everybody good with that? Because you're likely going to see something like that on the next exam also. So you have to know how to deal with raw data at this point. And typically, sometimes I put that more on the final also, but okay. And if I were to hold a study session Monday afternoon or sometime Monday, is it a possibility that you guys could attend and ask last minute questions to help you get ready for Tuesday's exam? Okay? Alrighty. So keep an eye out on email, and you have some classes. Rowan, what time are your classes? Ten and 1. Does your 1 end at 2:15? Okay. I was looking at maybe doing like from 1 to 3. So you could catch the last 45 minutes in that case if I do those. If I do that time, plus it would be recorded. And again, I'm only a text away. So thank you guys for attending. I need to get busy for college algebra because, well, yeah, I've got 1 minute, less than 1 minute. Okay, guys, I got to run. I'll talk to you all later. You're welcome. Take care. Bye-bye. Holler at me if you have questions getting ready for the exam.